Aloha, this is Gigi from Kauai Community College. In this video, we will be talking about the chain rule for taking the derivative. If you are in my class, these are the blue cards, number 16. And here we go. The problem asks you to calculate the derivative of the function g of x is equal to e to the sine of 5x. So when you look at this function, you should be looking at the structure of how this function is built. The first outermost function is e to the u power. Okay, so when you are taking the derivative of e to the u power, you will have itself. That's the wonderful thing about the derivative of e to the x, right? That's what makes e to the x an awesome function. Okay, now the second thing that we should be looking at is the function sine of, let's call this w, right? And if we were to take the derivative of that, we would have the derivative of sine is cosine. So that would be cosine of w. Okay, so that's the second function that is contributing to the g of x. And then the last thing that we have there is the derivative of 5x. And the derivative of 5x is the constant 5. So with these three things going on, okay, we can now apply the chain rule to take the derivative of g of x. And the chain rule said the derivative of a composite function is the derivative of the outside function evaluated at the inside function multiplied by the derivative of the inside function. So the outside derivative would be e to the, keep the input the same, sine of 5x. That's this one. Okay, so that would be the derivative of the outside function. Okay, multiplied by the derivative of the inside function. And the inside function is a composite function as well. So we have to multiply by the derivative of sine, which is cosine of, keep the input the same, 5x. And then multiply by its inside function, which would be 5. Okay, so what can you do with that? Really not much, except for just writing it neatly. So the derivative of g of x is going to be 5e to the sine 5x multiplied by cosine of 5x. And that is it. That's all you could have done. There's no like terms to combine, and there's no factoring needed. That is it.